This is a screencast podcast on moles, and it's going to go through what a mole is and how to work mole-related problems in chemistry. So, before we begin, we need to understand how we measure things. Here we have some different measurements. A dozen is 12, a gross is 144, and a ream is 500. If I was going to be a textbook publisher, I would order things, paper specifically, in reams. I wouldn't be counting 1, 2, 3, 4, 5 pages. I would order 500 sheets of paper in a pack like you buy at Staples or Office Depot. So if you look, here I have 1 dozen. That's a number that you're very comfortable with. So let's do a problem. Let's say I have 136 donuts, and I'm going to misspell donuts, okay, because items in this case we're going to make donuts. And I want to know how many dozen that is. Well, you can do it this way. I'm going to put the word donuts down here, and the word dozen up top. And we all know that in 1 dozen, there are 12 donuts. And so, on my calculator, I'm going to go ahead and take 136 times 1 divided by 12, and that's going to equal 11.33 dozen. And how does that work? Well, I'm using an equivalency. This is my equivalency. I've written it like this because donuts are going to cancel out. Words up top go down bottom. You put what you're changing it to up here, and then you fill your numbers in, and then you do your math. So what's a mole? Well, a mole is a unit of measurement. 1 mole is equal to 6.02 times 10 to the 23rd items. That's a lot of items. Well, in chemistry, we're going to be using things like molecules and ions, so we need to have a huge number to make all small particles manageable. So before we begin, we need to discuss that there's 3 ways to measure anything. So let's go back to our dozen. If I have a dozen donuts, a dozen vanilla frosted sprinkled donuts from Dunkin' Donuts, that means that I have 12 donuts in my box. Okay, they're those special sprinkled donuts. And everyone in class goes to buy a dozen of the same donuts. They're going to have a box that's going to take up the same amount of space, whatever that space is. Here's my box, right? Okay. And if I have the mass, if I could find the mass of my donuts, then the mass in grams would be the same for all of them. What if I had a bag of rice? If I had a bag of rice, I'm going to keep tapping here, and that bag of rice was 50 pounds. So you have a 50-pound bag of rice, I have a 50-pound bag of rice, everyone has a 50-pound bag of rice. So it weighs 50 pounds. That's a big old bag of rice. 1 bag of rice. It's huge. It's hard to lift. Your bag of rice takes up the same amount of space as my bag of rice. And if we dump it on the ground, the number of grains in everyone's bag in the whole class is going to be about the same. Okay, it's going to be about the same between your 50-pound bag and my 50-pound bag. So bottom line is we can measure mass, volume, and number. Those are the 3 things we can measure about anything. So we're going to have a map for success for using moles in chemistry. You need to memorize this. We're going to find the mass in grams, and to do that, we're going to use the periodic table, and we're going to do something called the gram formula mass. We're going to measure the volume in liters at something called STP. This is standard temperature and pressure. That's because if I change the temperature or the pressure, I can actually change the volume of something I have, of a gas. Now, 1 mole is equal to 22.4 liters, so that's my volume in liters. And here, to go down to number, and the things we're going to use, the particles, okay, our number here, so our particles down here are words like ions, atoms, formula units, and molecules. And these are different entities because this measures covalent, this measures ionic, so it's like NaCl, this is like CO2, an atom is just that Na, and an ion is something like Na+. So that's if you and I really want to understand what we're saying, that's what those different words mean. And the number, good old Avogadro's number, Amadeo, avocado, or Avogadro, the Italian scientist, came up with 6.02 times 10 to the 23rd particles equals 1 mole. And that's why we're going to draw a mole here. You need to have this memorized. Copy it down. So, before we begin, we need to know how to find the gram formula mass. Now, remember that word formula on the other page? I can also write molecular. I can also write atomic, and if you notice, this word in the middle really doesn't matter. I'm finding the mass in grams of my molecule, my formula, or my atom. I can also call it molar mass. Bottom line, I'm going to find the mass in grams of whatever I have in front of me. So this is sodium chloride, NaCl. And what that means is I have 1 sodium and 1 chlorine in sodium chloride. This is carbon dioxide, so we finish with this for a second. This is carbon dioxide. I have 1 carbon and 2 oxygens in a molecule of carbon dioxide. Now how do I find the mass? I look at the periodic table, and that's going to be a fancy word called the gram formula mass. So if you look at the periodic table, in oxygen's box, carbon, chlorine, and sodium, there is the mass. That's this number down here, the decimal number. Up here is the atomic number. This is the mass of my element. So, in sodium's box, get your own periodic table, I have 22.99 grams, plus chlorine is 35.45 grams. And that equals 58.44 grams. And that equals 1 mole of NaCl. That's the equivalent of 1 mole. Now how do I do carbon dioxide? Carbon is 12.01 grams, oxygen 16, and there's 2 of them. So when you add all those up, that equals 44.01 grams. What's that equal to? The GFM. That's equal to the mass of 1 mole. And it turns out that in every single box on the periodic table, that's the mass of 1 mole of my element. And that's why each of these, when you add them up, the GFM equals 1 mole of whatever you have in front of you. In this case, sodium chloride or carbon dioxide. So let's do some problems. These are called one-step problems, and that's because they have 1 step. So you're going to underline that you have 38 grams of sodium chloride. That means you're right here. You're at mass in grams. You need to find out how many moles. So I start with 38 grams of sodium chloride. I do not want that, so I put grams of NaCl down here. I'm going to change that to how many moles. And I'm going to go ahead and put the word mole over here. Now, I'm probably a step ahead here. So if you look at it, I start with grams, right? That's what I start with. I put that right here. I take my words and I put it down here so that they cancel. And then I say, where am I? I'm on mass and I'm going to moles. What do I pass by? I pass by the periodic table and I've got to find the GFM. I am going to land on I'm going to land on moles, right here. And so there's 1 mole in that mole hole. The GFM of NaCl, we just figured out on the other page because we've clicked 1 box for sodium, 1 box for chlorine, and that added up to equal 58.44 because sodium is 22.99 and chlorine is 35.45 grams. You add them up and you get this right here. So to solve this problem, I do 38 grams times 1, I forget about that, divided by 58.44, and I get 0.65 moles, 0.65 moles, which makes sense because if 1 mole equals 58.44 grams, and I have 38, I have less than a mole, so 0.65 moles. Let's do another one. Here I have how many grams are in 4 moles of water. Now I know I have 4 moles of water, so I start with 4 moles here. That means I'm on my mole map, on my mole hole, and I'm going to grams. Grams are over here. That means I need to go in this direction, this line right here, right? So I do not want moles. I do want grams. In my map, on my map, I have 1 mole in that mole hole. And now I need to add up water. So I add up H2O. H2O. That's 1.01 grams plus 1.01 grams plus 16. 15.99 grams rounds to 16, and that equals 18.02 grams for water. That's something you might want to tuck in your memory. Okay, so now how do I do my math? I take 4 times 18.02, and that equals 72.08 grams. And look at that. That matches my moles. Cancel out, and I'm left with grams. Let's try another one. Now I have 2 moles of chlorine gas. How many liters? So what do you start with? 2 moles of chlorine gas. Remember that's diatomic, right? Brinkelhoff, H7, or GNUN. So there's your ine, right? So I don't want moles, so I'm going to put the word moles down here. I want liters, so I'm going to put liters over here. I'm going to say, where am I? Looky here, I'm on moles. And I'm going up to liters. What do I pass by? 22.4 liters, not periodic table, not 6.02. So I have 1 mole. I'm leaving that 1 mole. I put liters up top. What do I pass by? 22.4 liters. And 2 times 22.4 is 44.8 liters of chlorine. Let's do another problem. Here I have 12 moles of lithium chloride. I know I have 12 moles. I start on 12 moles. And by the way, if you notice, these are all 1 step, aren't they? I'm going 1 step. I'm going 1 step. See that? So I have 12 moles of lithium chloride, which is LiCl, because that's +1 and -1, so that makes that compound. I do not want moles, so I put the word moles down here. I know I'm going to formula units. I'm going in this direction. This is where formula units are. What do I pass by? Not my periodic table, not 22.4, but 6.02 times 10 to the 23rd. So I'm leaving moles. I'm going to formula units. I write formula units up here because there's a direct path. I write formula units over here, so my answer is labeled. I put 1 here because there's 1 mole in my mole hole. I write down what I pass by, 6.02 times 10 to the 23rd, and now I do my math. When I do my math, I'm going to end up with 7.22, and then on my calculator, I see E. That E means times 10, and if you look right next to that E, you have a 24th. That's my answer of lithium chloride. Okay, let's look at this one. Here I have 1.2 times 10 to the 24th molecules. I'm down here. Where do I want to go? I want to go up to moles. This is a one step again, isn't it? How many moles? I have 1.2 times 10 to the 24th molecules of carbon dioxide. I do not want molecules of carbon dioxide. I do want moles. And because there's a direct path, I can go ahead and put the word moles up here. How many moles in the mole hole? 1. What do you pass by? 6.02 times 10 to the 23rd, not 22.4, not the periodic table. So I write 6.02 times 10 to the 23rd because that's what I pass by going between molecules and moles. Now, when this is on the bottom, my scientific notation, I need to put this in parentheses. Back here, I did not need to put it in parentheses. But if you forget, then you always put scientific notation in parentheses so you don't get it wrong. So this has to be in parentheses on the bottom. If I forget, I'm going to go ahead and put it in all the time. And if I do my math, I'm going to end up with 1.99 moles of carbon dioxide. I take 1.2 times 10 to the 24th times 1, or not, divided by 6.02 times 10 to the 23rd, and I get 1.99 moles of CO2. And this is a similar problem, so let's do this one. Okay, so now we're going to go to two-step. Why is this two-step? Because I'm going to start on one part. I'm on grams, right? That's mass in grams. And I have 38 grams of water vapor. And I'm going to go from grams to moles and then up to liters. Why liters? Because I don't know how many liters. So because volume in liters is up here, I'm going to have to do two steps. I'm going to have to change my mass in grams using the periodic table. So I put grams down here. I put the word mole up here because this is the step I'm on right here. There's 1 mole in that hole. Okay, so in the hole there's 1 mole. That H2O is 18.02, right? 1.01 plus 1.01 plus 16. I'm getting those off the periodic table. That 18.02 goes right here. Now, does my problem ask for moles? Nope, it asks for liters. So, I take my words up top, my moles, right, my grams canceled. My moles I want to cancel, so I put moles down here and liters up top. What am I physically doing in this? This step, I'm leaving moles, I'm going to volume. So 1 mole goes here, because that's how many moles are in the mole hole. What do you pass by? 22.4 liters. And so there's your directions. So what do? 38 divided by 18.02 times 22.4 gives you 47.24 liters of H2O. That's called two steps because I did 2 steps. Let's do another one. Here I have 3.6 times 10 to the 23rd formula units of sodium chloride. That means I'm down here. If I circle how many grams, there should be a line there, I'm going to go over here, aren't I? So what are my two steps? My first step is to change formula units to moles, and my second step is to change moles to grams. So I start with what I underlined, 3.6 times 10 to the 23rd formula units of sodium chloride. I do not want that, so I'm going to put the word formula units down here and change it to moles. That's this step right here. How many moles in that whole? 1. What's the number you pass by? 6.02 times 10 to the 23rd. So that goes down here. And again, what do you do when you ever divide by 6.02 times 10 to the 23rd or anything else in scientific notation? Let me erase this. Okay. Oops. Sorry. Come on. I'm going to put that in parentheses. If I forget when to do it, I do it all the time. So what's my second step? Because moles is sure not what I want. I want how many grams, which I can go ahead and label over here if I want to, so I can remember where I'm going. I do not want the word moles. I do want the word grams. And I'm going to get rid of my one mole. I'm going to go over to mass. And what do I pass by? The periodic table. I'm doing NaCl. Remember, NaCl was 22.99 plus 35.45, and that was grams off the periodic table, which equals 58.44 grams, and that goes right here. That's my GFM, my gram formula mass. Now how do I do my math? 3.6 times 10 to the 23rd divided by 6.02 times 10 to the 23rd in parentheses times 58.44, and I should get 34.95 grams of sodium chloride. Let's go ahead and do one more. I kind of hand wrote this in because I want to give you every single leg of my map. So if you look now, what do you have? You have 1 mole in the middle, all right? And what do you know? You know you have 1.32 liters, so aren't you starting up here and you're going down to moles? You don't know grams, so then you're going to go over here. This is step 1, and this is step 2. So what are you going to do? You start with 1.32 liters of oxygen. You do not want liters, so you put liters down here, and you change it to moles. This is your first step. So I have 1 mole in that mole hole, right? This is my step. That's where I'm driving towards. What do you pass by? 22.4. So I put 22.4 liters. I'm not done. My liters cancel, don't they? Liters cancel. I'm left with a mole. That's what I want. So in my next step, what do I do? Okay, and I actually should have written this in red for you so you can follow that that's the first step. What's my second step? My second step is to change moles to grams. I don't even know if you can see that. So you know what, I'm going to change the color so you can. So this is my step right here. Actually, let's go ahead and use pink. That's so close to red, isn't it? Oh well, you get the idea. So this is moles here. There, it's better. Okay? So what am I going to do? I do not want the word mole. There's one because there's one in my mole hole. How many grams do I have? Well, if I have oxygen, where do I look? Periodic table, the GFM. So I'm going to look in oxygen's box. There's 2 of them. So I'm going to go ahead and click oxygen and oxygen. That's 16 grams plus 16 grams. That's 32 grams equals 1 mole. So 32 grams go here. And how do you do your math? 1.32 divided by 22.4 times 32 equals 1.89. And how am I going to label my answer? In grams, because that's what I want to know of O2. Hope this has been a good review. There's some real cool links here. There's 2 songs, and there's just a fun mole song. I think it's from Czechoslovakia, from a cartoon. So you take care, and I hope this helped. Bye.